Hey, welcome back. Today we're talking in geometry to show that a quadrilateral is a parallelogram from section 8.3 of our book. Today we're going to talk about a couple different types of theorems. The first one is theorem 8.7. Again, just to preface, it's okay if you don't necessarily know the theorem name, but as long as you can explain some type of meaning about it, you should be okay. Or explain some type of meaning about a quadrilateral. So if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So all that's kind of saying is if you have, here's my quadrilateral, if I said that both pairs of opposite sides were congruent, then the quadrilateral would be a parallelogram. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So again, if we have our quadrilateral. The only thing that they show us is that the opposite angles are congruent. Then this is a parallelogram. If one pair of opposite sides of a quadrilateral are congruent, and parallel, then the quadrilateral is a parallelogram. So again, just kind of showing you here off to the side. Now these are not super great. I got to redraw that one. That one's rough. Maybe it looks something like this. Okay. It shows that these are congruent, and then remember that little triangle just shows parallel. Okay, then the quadrilateral is a parallelogram. Yes. And it could be the other two sides, but essentially it would say congruent and parallel. And then the last one here, theorem 8.10, if the if the diagonals of a quadrilateral bisect each other. We did a lot of this in our warm-up today. Then the quadrilateral is a parallelogram. So right there's some different ways to tell. Again, I'm going to just draw a rough quadrilateral. There's my diagonals. By showing these markers, that means that those little pieces of those diagonals are congruent, which means that because there's a bisector, and that this is a parallelogram. So we're going to look at these different figures in example 1 and 2, and just determine supporting the knowledge that they are parallel. So the figure shows part of a stair rail. Explain how you know the support bar MP and NQ are parallel. So what we want to do is we kind of want to look through some of our notes. And so you look in particular at this first one here. It says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So by short, I'm going to say here, theorem 8.7, which you see at the top, states opposite sides congruent, then the quadrilateral is a parallelogram. Thank you. And if the figure is a parallelogram, then the sides are parallel. So because you've got two sides that are 3 and the other two sides that are 2, that means that those sides, opposite sides, are congruent, which then makes it a parallelogram. If it is a parallelogram, we learned in the previous lesson that by definition, a parallelogram, opposite sides are parallel. Means that these two sides would be here, and then these two sides would be parallel as well. Example number 2. In a quadrilateral, WXYZ, okay, and then it gives the measurements for those angles. Find the measure of angle Z. Is it a parallelogram? Explain your reasoning. First off, I really like to draw a picture. Let's go ahead, let's draw a picture. I'm just going to make this a little bit slanted just because of the way that it says those different measures. So W, we're going to say 42. X is 138. Y is 42. And then it wants us to find out what Z is. So it's a quadrilateral, so it gives us that. How many degrees in a quadrilateral again? Does anyone remember? Yep. 360. Okay, so why don't we take 360 and let's subtract 138 and 42 and 42 and see what you get. Okay. So we have right now 42 and 42, we have one pair of opposite angles that are congruent. So if we can determine that the other pair of opposite angles are congruent, then it's a parallelogram. Based on that theorem, what was it? By name, it says Theorem 8.8, I think it is. But it states that if both pairs of opposite angles of the quadrilateral are congruent, then the quadrilateral is a parallelogram. So does anybody plug this into their calculator? Does anyone know what you get? Yeah, right. 138. Okay, so that's great. So because we have this as 138, okay, by theorem, say 8.8, or opposite angles are congruent, this is a parallelogram. And it does have to be the both pairs of opposite angles are congruent. Any questions so far? All right, let's go ahead and move to this next one here. We really don't have that much. Example 3 says, for what value of x is quadrilateral RSTU a parallelogram? 4x, by the way, is not the angle. It's that measure here. So this is what we're looking for, is 4x compared to, the 4x is compared to the 8x minus 32. What could we do to those in order to determine if this is a parallelogram? What about diagonals do we know is true? We talked about at the very beginning of class. They're always bisecting. So we could actually say here that 8x minus 32 is equal to 4x. So then if I subtract 4x from both sides and add maybe 32 to the other side, so it moves over, I'll end up with 4x is equal to 32. 8x minus 4x is 4x. Add 32 to the other side, it becomes positive. Divide by 4, and x would have to equal 8 in order for this value to be true. Example 4 says, state the theorem you can use to show that each quadrilateral is parallelogram. If you can't state the theorem, that's okay, but at least state kind of the basis of one of the things that we learned within those 4 different theorems at the very beginning. Take a look at what this first on the left, what this parallelogram is saying. It's saying that both those sides are parallel and that both of them are 30 meters. Looking back through your notes, what theorem says about parallel and congruent? Lola? Theorem 8.9. Good. One pair of opposite sides is congruent and parallel. You could have also said that as well. Take a look at that other one there, 65, 115, 65, and 115. Which theorem, or what's it kind of explaining? Theorem 8.8. Good. And Theorem 8.8 states that if you have opposite pairs of angles congruent, then the quadrilateral is a parallelogram.
Could that be an answer to the test? Could you just put the theorem?
You could, if you like it. That's a good question. Could you just put the theorem? If you had a question like this and you just put the theorem number, I would totally be okay with that. If you know what those theorems are, I mean, if you're that good with them, then by all means, just put the theorem number, and then you should be good. The very last question I have for you today kind of deals once again with the coordinates, the coordinate plane. So we've got FGH is a parallelogram. We're going to kind of tie back a little bit into some prior knowledge here whenever we're looking for this, because we're going to be finding slope, and we're also going to use distance formula just to kind of get your brains going again on those. Show that the quadrilateral is a parallelogram. Okay. There's a bunch of different ways that we can find out if this is a parallelogram. We could use distance formula to find both sides are congruent to each other. Both opposite sides are congruent to each other. We could use slope to find that the angles are, congruent to each other. We could find one pair of opposite sides congruent, and that they're parallel to each other just by finding the slope. That's what I'm going to use for this one, just so you guys kind of get that, get the idea of both of those different skills, the finding the slope and also using the distance formula. So I'm going to first start off with the slope. I'm going to start off with the slope of FJ. I think that's probably the easiest one to do there. We've got the point -3. Let me write that a little cleaner here. -3, 1. And then we've also got the point of -1, comma 0. So I'm going to write this as, remember our slope formula is y of 2 minus y of 1 over x of 2 minus x of 1. So we'll have 1 minus 0 over -3 minus -1, or 1 over -3 plus 1, which is 1 over -2. After that, we'd also want to find the slope of GH. So let's go ahead and look at those coordinates. I've got the coordinate of 2, 6, and another coordinate of 4, 5. I'm going to plug those in. So 6 minus 5 over 2 minus 4 gives us 1 over -2. So we definitely know that FJ is parallel to GH. That's part one of it. Part two, then we could find out the distance between them. So as a reminder, distance formula x of 2 minus x of 1 squared plus y of 2 minus y of 1 squared. So if I'm finding the distance between fj, let me scroll this down just a little bit. I would say that I've got negative 3 minus negative 1 squared plus 1 minus 0 squared, which ends up giving me negative 2 squared plus 1 squared, which is going to end up being 4 plus 1, or the square root of 5. I'd also want to find GH. So GH, I've got 2 minus 4 squared plus 6 minus 5 squared, square root of negative 2 squared plus 1 squared. Hopefully from there, if you're just looking at these up and down, you notice that these are going to be the same. Square root of 5. So we can say that fj is congruent to gh. Okay. So since one pair of opposite sides is congruent and parallel, this is a parallelogram. And if you wanted to get technical with it, that I believe is theorem 8 and 9. And that should be all for our notes today.